Okay, let's get started. So prove that if function of x is equal to square root of x, then f prime of x is this right here. So we don't even need that information. We just need to follow the standard. So let's replace that with Alright, so this is going to be again the limit as h approaches 0. And we're going to use the quotient function here. There we go. So now all we have to do is plug this f of x into this formula. So now, and I'm going to take this limit and continue it. So going to have basically the square root, and let's see where square root's right here, of x plus h, right, plus the square root, okay, so we're going to have square root again, of x over h. Okay, got that. So now, let's see. The best way I think to get rid of this is to, oh, I'm sorry, I made a big mistake. Quotient, this is subtracting. Sorry. So, best way I think, I just realized that the reciprocal form looked unfamiliar when I was thinking about it in my mind. And now the best course of action here is to multiply by the reciprocal if you haven't already figured that out. So let's multiply by the reciprocal. So it's reciprocal of this. So I'm going to have a fraction here plus. Alright. So now we're up to this step here. So once we, let me make a new line. And, okay. So now we can get rid of this part. So what's square root x plus h times square root x plus h? Yeah, and you can look here to see square root x plus h times square root x plus h is just going to be x plus h. And then we have these intermediate multiplications, square root x plus h times x, and then you're going to have the negative form of that, and they're going to cancel out. And then you have negative x times negative square root x times positive square root x, which just turns out to be x. But we still have our reciprocal in the denominator. Important note. So let's stick that in there now. Go x plus h, right, plus the square root of x. So this is where we are. I don't know why I have two equal signs there. Okay. So now this is where we're at. So what do we know from here? Well, we can see clearly that this x is going to cancel out with this x there. So these x's cancel out. And let me show the intermediate step, I guess, just for clarification. And then you're going to, once these are eliminated, this h in the, let me put that next to that, this h in the numerator is going to cancel out with the h in the denominator, right? So just to illustrate, that cancels out with that, and this is of course multiplying 1, and 1 is left in the numerator. So let's go to our next step from there. So we have 1, and now we have our denominator here. So as h approaches 0, right, we can, now that it's within this domain, we can actually just sort of plug it in, right? So this is going to be equal to h actually equaling 0, right? And now going to be 1 over square root of x plus x, which is going to be 1 over 2 square root x. So we just found our, let me go to the beginning here, f prime of x is equal to 1 over square root 2x, which is what we had in our beginning. So hope this helped.